So we are going to solve a question where we have to find last digit of x power n. Okay, so let's say if we have to find 10 power 11, this number is nothing but 1 followed by 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say if I want to find 2 power 4, this number is nothing but 2 to the 4, 4 4 the 16, right? So what you are given is, you are given two numbers. Those numbers are x and n, and you have to find the last digit of this x power n. So whatever is the answer, in that answer you have to find the last digit and print it. So for 10 power 11, our answer will be nothing but 0. For 2 power 4, answer will be nothing but 6. So this is the question. Now, this question would be very simple to solve in any language, because in every language we have a power function which takes two value x and n, and it will give you x power n. Whatever answer you will get, you will just do answer modulo 10 and you will get the last digit, right? But here, if you look at the constraint, what I'm writing, what it is saying that x, length of x, that means number of digit in x, can be any value between, let's say, 1 and 10 power 6. So let's roughly take, see like how much value we can store in integer. So for integer, the maximum value we can store is around 2 power 31 minus 1. That is nothing but 2 into 10 to the power of 9. If we take this number 2 into 10 to the power of 9, here we can store around 10 digits. This is nothing but 10 digits. Let's take long. Long is nothing but 2 power 63 minus 1. That is almost near 8 into 10 to the power of 18. This is around 19 digits, right? But we are given a number x which has 10 power 6 digit. It can have 10 power 6 digit. Okay. And there is another number n which is anywhere between 10 to the power of 6 and 0. Okay. So now, if you look at this power function in C++ or Java, it will not be able to calculate x power n. Why? Because x is very large number having 10 power 6 digit. In long at max, we can store 19 digits or 20 digits. In integer, we can maximum store 10 digits. And this has 10 power 6 digits. So you can just imagine how big that number is. But still, in Python, because it supports like very large values, you can easily solve this question using power function. Also in Java, you can use big integer, and C++ you can use big integer. But we can also solve this question easily by using integer. Okay. So let's see how we can solve this question. So if I ask you what is 1 power 0, this is nothing but 1 power 1, 1, 2 power, sorry, let's not take 2 now. Let's take 1 power 2. This is also 1. 1 power 3. This is also 1. 1 power 4. This is also 1. 1 power 5. This is 1. 1 power 6. 1. 1 power 7. 1. 1 power 8. 1. Now let's take a 2. 2 power 0 is 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. 2 power 8 is 128. 2 power 9 is... Did we miss any number? Yeah, 2 power 7. This is 2 power 8, 256. 2 power 9 is 512. 2 power 10 is 1024. Similarly for 3, 3 power 0 is 1. 3 power 2 is 9. 3 power 3 is 27. 3 power 4 is 81, and so on. For 4 power 0 is 1. 4 power 1 is 4. 4 power 2 is 16. 4 power 3 is 64, and so on, right? Now here what you have to look carefully is, if you look at the last digit, okay, last digit of all x power 0, all x power 0, always the last digit will be 1, right? Always the answer is 1, also last digit is 1. So if n, can we say if n is equal to 0, always my answer will be nothing but 1, right? Okay, now let's leave that. Come to this point. You, for 1 power 1, its last digit is 1, 1 power 2, 1, 1 power 3, 1, 1 power 4, 1, and so on, all ones, right? But if you look at 2, just the last digit, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 6, then 2, then 4, then 8, then 6, and 2, then 4. Now, if you see at the last digit, you are just getting these numbers 2, 4, 8, 6, again 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. If you look at here, you're getting 9, 7, 1. Now, next number, if we try to find, it will be nothing but into 3 if we do. 3 1s are 3, 8 3s are 24. This is... Okay, we missed here 3 power 1. That is nothing but 3. So 3 9 7 1. 3 1s are 3. 3 8s are 24. So 3 power 5 is 243. Here you are getting 3 9 7 1 3 again, right? Next number, if you see, if you multiply it by 3, you will get 3 3s are 9. So here we are getting this 3 9 7 1, again 3 9 7 1. Here if you say, you get 4 6, again 4, again 6. So if you multiply it by 4, you'll get 4 4 is 16. So 3 9 7 1 for this, 4 6 4 6 4 6 for this. Now let's take one more number left to verify 5 power 0 will be always 1 because n is equal to 0. Let's take 5 power 1. It is 5. 5 power 2, 25. 5 power 3. Last digit will be always 5. So if we take 4 number, cycle of 4, this will be always 5 5 5 5 5, right? So can we say this, that the 4 last digit, the last 4 digit, if you see, those will always form a cycle. Here if you take, it is 1 1 1 1. Here if you take, it is 2 4 8 6. Here if you take 3 9 7 1. Here if you take 4 6 4 6. For 5 it is 5 5 5 5, right? Correct. So if we know this information, instead of finding x power n, can we reduce n? Can we reduce n to n modulo 4? Yes, but there is slight modification we have to do. If you take 4, actually 4 modulo 4 or 8 modulo 4 will give you 0. 7 modulo 3 will give you 3. That's fine, like these answers will match, but here you'll get 0, right? So what we can do is we can write n will be equal to nothing but if n modulo 4 is equal to 0. If n modulo 4 is equal to 0, then we'll make n as 4, else we'll make n as n modulo 4. So I am using ternary operator. This is nothing but if n modulo 4 is equal to 0, n will be 4, else n will be n modulo 4, right? Okay. So now we have reduced our n. N was not big number, it was 10 power 6, but even though now the possible answer for n, now n will get reduced to either like 0, 1, 2, 3, because we are doing mod 4. If we do mod 4, we can get either of these values, 0, 1, 2, 3, right? We are changing n to 4 in case like n modulo 4 is equal to 0. So the value of n now will be any of one of these, 1, 2, 3, 4, right? See, we have reduced n to very small number. Okay. Now if I ask you this question, what is 10 power 0? It is 1 only. If I ask you 10 power 1, now let me ask, just look at the last digit, okay? So 10 power 1, what will be the last digit? 10 power 2. If this is 0, 0 power 2 will be how much? If you do 0 into 0, you get 0. Okay, just ignore 10. Now let's look at this number 11. 11 power 0 is 1. 11 power 1 is 11. 11 power 2 is 121, right? 11 power 3. Like if I do 11 into 11 into 11, will the last digit will remain 1 only? Yeah, 11 into 11 power 4, last digit will be also 1. Similarly, if I take 12, 12 power 0, last digit will be 1. 12 power 1, last digit will be 2. 12 power 3, 12 power 3, last digit will be 12 power 4, last digit will be 6. 12 power 5, last digit will be 2. 12 power 6, last digit will be 4. Now let's take 13. 13 power 1, last digit is 3. 13 power 2. If you multiply 13 into 13, 3 is a 9. Last digit is 9. 13 power 3. You multiply 3, 3 9 is 21. Last digit will be 1. Right? So whatever is answer for 2 power 1, the same answer will be for 12 power 1. Whatever is the answer for 2 power 6, same answer will be for 12 power 6. Right? Whatever is the answer for 4 power 1, same answer will be for 14 power 1. Same answer will be for every number ending with 4. Same answer will be there for every number ending with 3. Right? So now can we write, instead of finding x power n, can we take the last digit of x and find x power n? Yes. So we can reduce to x is equal to x modulo n. So now if you see, n is reduced to, let me write it again. X is now reduced to x modulo 10 and n is now reduced to, if n is n modulo 4 is equal to 0, then n will be 4, else n will be n modulo 4. So the possible values for n is nothing but 1, 2, 3, 4. Possible values for x is nothing but 0, 1, 2, 3, and so on up to 9, right? Now here, if you take the largest value, that is 9, and here the largest value is 4, finding 9 power 4 is very small number, and you can easily get this, and you can do whatever answer you get here. You can just print answer modulo 10 because you have to print the last digit, right? Now let's quickly walk through the code. So this is the question where you are given very large number x and integer n. You have to print the last digit of x power n. The constraint we have already talked about. Let's walk through the code. So yeah, this is the Java code. So what I am doing is, because here we had number of test case, so we were taking number of test case. For each test case, we are reading two values. One value is x. Now, as I said, x is a very large value. We cannot read it in integer. So I read it in a string, and I'm just taking the last digit. Okay. So because this is a character, to convert it to digit, I'm taking the last character and doing minus the ASCII value of 0. So I'll get the last digit here. Now I'm taking the next number, that is n. I'm just checking if n is equal to 0. My answer is 1, right? As we discussed, 1 power 0, 2 power 0, 3 power 0, 4 power 0, 5 power 0. All, when n is equal to 0, always the answer is 1, right? Else, we are modifying n and bringing n down to 1 to 4, any number. Finally, we are just finding last digit power n. Last digit is nothing but x last digit, and n is a small number, so we can easily use power function, or we can use for loop to iterate for n time and keep multiplying last digit, and then do modulo 10, and that will be our answer. It's very simple. Okay, thanks everyone.